Hello everybody, this is Avantik here. Today we'll be discussing about feature selection techniques. The agenda for today's discussion would be understanding what is feature selection, variance threshold, chi-square statistics, ANOVA using F-classif, univariate feature regression test using F regression, F-score versus mutual information for discrete value, mutual information for continuous value, select k-best, select percentile, select from model, recursive feature elimination. Let's start with introduction to feature selection. Introduction to feature selection. Selecting subset of features from the data set. Generally, data set might contain smaller number of features. Also, they might contain large number of features. Not all features are important for prediction, right? So what you want to do is you minimize the number of features that you want to use for prediction. Okay, that is where feature selection comes into picture. The benefits of feature selection are it improves estimators' accuracy, boosts performance for high dimensional data sets. What it means is data set which have very large number of columns. We'll discuss first univariate selection techniques. Okay, and later on we'll get into feature elimination method. The first technique that we'll discuss is variance threshold. Let's get started with that. Variance threshold. Okay. So you assume you have certain columns which do not show a lot of variation. That means most of the data are of similar type. So if that is the case, impact of such column on the target is expected to be less. So you can configure a threshold of variance. If any column shows variance lesser than that, those columns will be dropped. So let's see this data. We have A, B, C, 3 columns out here. Okay, and you can see this A is a categorical and B and C, of course, can be assumed to be continuous, though we have limited values over here. We are using label encoder to convert the categorical column like M and F into numbers. So you can see this. Eventually, everything is the numbers. Now, if you use variance threshold and configure a threshold of 0.2, so any column which has a variance of less than 0.2, it will be dropped. So if you use the transformer, the feature selector variance threshold, which is present inside feature selection package, okay, and this is the threshold you are configuring, and if you do vt.variances, it will show variances for all the columns, 0.1 for first guy, 0.5 for second guy, 0.5 for third guy. As you can see, this guy's variance is less than 0.2, so this particular column, the first column, will be dropped, right? As you can see here, only one value is different, rest of all is same. So only these two values are retained. Okay, and please note one thing, it does not consider the target, so it is an unsupervised technique for feature selection. After this, we'll get into chi-square method. Our topic for now is chi-square for non-negative feature and class. Let's see. Feature data should be booleans and count. This is one condition for applying chi-square technique. Okay, the feature data should be either boolean 1 or 0 or counter information. Okay, so it is of course not suited for continuous data, and target should be discrete. So let's use the tennis data that we have. Okay, so of course it has outlook as categorical values. We are converting that to numbers using label encoder. So eventually our data looks something like this and plays the target, which is a categorical value. So it's a classification, right? So if you configure feature selection chi-square and you're passing the feature data and the target data, it will return you the importance of all the columns. Okay, so as you can see here, higher value means more important feature which is contributing to the target. As you can see here, the second column, that is your temperature, is not very important in predicting whether the person will play tennis or not. Okay, so we can take these 3 features into consideration. So this is how chi-square actually works. Let's get to the next technique. This is ANOVA. So I'll leave the internal details of ANOVA for, you know, statistics sessions, statistics videos that you can, you know, watch to understand that. What will focus is where to use it. As you can, you know, see, chi-square technique be used for where the feature data is either Boolean or discrete. Okay, so all the features are categorical and the target is also categorical. With the classiv, you'll use where feature data is continuous in nature. So it's how this is. So if you have continuous column, you'll use ANOVA on top of it. If you have categorical columns, you'll use chi-square on top of it. So breast cancer data we are using in this case. So if you remember, breast cancer data has continuous values. All the columns are continuous visual feature, and the target data is discrete. Okay, so this is the data, this is the target. We are using feature selection and F-classif. So if you do so, we are getting all these values. Okay, higher the value, more the importance. Okay, so based on, you know, how much feature you intend to have, you can choose from these. Okay, so higher the value, more the important. That's what you need to understand. Okay, and classif will apply for continuous data. Okay, after that you will get into F regression. So the previous two techniques are for classification. Now going forward we'll see for regression. Okay, so now let's do univariate regression test using F regression. Linear model for testing individual effect of the many regressors. Okay, what does it mean? The predictors. Okay, the regressors in the case. You want to find what is the importance of each of them, right? And of course, expected continuous values over there. So what it does internally, it finds a correlation between the feature data and the target data. Okay, so we are using California data, in this case California housing data, and if you use F regression, you get some of these values as a result. Okay, this is a F score value. Okay, F score tells you what is the linear relationship between the values. Okay, so that's what. So these values that you see here is the linear relationship values. So higher the values, those have higher impact on the target. Okay, as you can see, this is also supervised technique as you are passing the target over here. The next thing we need to understand is F score versus mutual information. Okay, F score basically tells you how much, you know, the features are related in terms of linear relationship. As you can see, if you have this X column and this is your Y, and you can see a linear relationship over here, right? So let's just plot the data, and if you see this is not really linear. It's a sine curve here, isn't it? So we'll see, for this situation, we'll see that F regression will be higher in case of these values, whereas it will be lesser in case of these values, to handle situation like this where the data is dependent to each other, right? Y is your dependent on X, it's varying with X, but it's not really linear relationship. In this situation, mutual information comes into picture. So for linear regression, linear relationship, you have linear regression and F-classif and all that. But if it is non-linear relationship, but still there is some dependency between X and Y, you can use mutual information there. For the above data, okay, what we saw here, the mutual relationship can be calculated using mutual info classification and mutual info regression. Let's see for regression as the above data regression, and it is giving you this particular information, right? So as in this case, we have X, which is 3 column, and Y, which is a function of X. As you can see, the first relationship is X, the second one is in sine curve, third one is constant, right? So when you try to find out the relationship with X and Y, as you can see here, this is the mutual information. Regression is very high. This is the second column, right? I'm printing the second column over here. This is the first column, right? Third column, of course, it's a constant number. We haven't printed it. Okay, so this is the second column over here. So as you can see, the mutual information is high for second column and target. Okay, but less for linear relation. So if you want to find linear relationship, you'd be using F regression. If you want to find mutual information between two data, you'll use mutual information regression. Okay, let's now move into classification. So we'll use income data in this case. We have seen this data earlier also, just loading the data. And we are getting all the categorical columns from here, removing the salary column, which is the target. Okay, rest of the column I'm picking up here. And if you do mutual information class, it tells you, which are the important, these values basically tells you the importance of it. Okay, and that's how we can understand the importance of these columns. So all the above methods are really techniques, but we want a generic method which can use all those above techniques, and that is what select k-best is. In select k-best, you can configure which above technique you want to use. For the same data above, you are configuring here the score function. You're configuring that you want to use fclassif, and you're telling it number of features over here. Okay, k features. K is 7. So among all these features, you'll use top 7 important features. You may change the technique here, you may change the number here, you'll get it accordingly. So after this, feature selected is ready, you can use this guy, pass the data to it. This is the feature data, this is the target data. It will return you those important 7 columns. Okay, and if you want to find importance of all these columns, dot scores underscore will give you values suggesting the importance of these columns. Okay, this is similar to select k-best. We have select percentile. Here you can configure the top 10 percentile. By default, it will be top 10 percentile of features that it will return. Here we are configuring 20. So top 20 percentile features. Okay, that is how you control it. Right? Everything is same. Like scoring function, here you might choose one of the above technique, mutual info classif, fclassif, right? Depending on what is your feature data, what is your target data, you can choose your scoring function. And percentile will control how many feature it returns. Let's now see the next guy, which is select from model. It uses machine learning models to find importance of features. Okay, so for example, in this case, we have a linear regression over here, and just the important point to note, the model that you're using over here should support the function feature importances. Okay, so linear regression is there. As we understand in linear regression, higher, if the value is standard scale, higher coefficient means that feature is more important. Okay, so you select from model, you're passing the model and giving a threshold over here. So it will return, from the mean. Okay, we'll start with select from model again. The next one is select from model, selecting importance of features from model weight. Okay, for example, if you're using linear regression, and the features are scaled, then the higher coefficient means the feature is of higher importance. Okay, so and make sure the model that you're passing over there supports feature importance function. Okay, feature importance parameter. It will return how importance of each of the features. And when you configure here, this is the linear regression that you are using. This is the model and threshold 0.25. That means the features which are from the mean importance of features which are 0.25 higher than that, it will return those features. So as you can see, the data consists of 13 columns and it returns 7 out. We'll go to the next. Okay, let's get into recursive feature elimination technique. It uses an external estimator. Okay, say in this case we are using SVR, right, which is a support vector regressor. This is how we are generating the data. This is the support vector regressor, and we are mentioning linear kernel over here. And what it tries to do here is the model that you are using, it has feature importances attribute, which returns importance of each of the features. It will try to remove a couple of features which are of least important, then again train the model. Okay, then again find the features which is of least importance and remove that. So it is like it eliminates the feature every time it trains itself on the data. Okay, till the time it finds out number of features that you are interested in. In this case, you are interested in 5 features. So initial data is 10. So it continues deleting all the features which are of lesser importance and eventually get to 5 features. Okay, so you can use all these techniques to identify important features, but please take into consideration the data, the target. Okay, and that's all from feature selection methods. Thank you.